Hey Daisy.
Hey, how was your day?
Pretty good. How about yours?
It was good. Where are you off to?
I think I'm gonna go to the CRC, maybe work out a little bit. You know, spring break's around the corner, so I think I'm gonna go there. I'll see you later though.
Whoa, you can't go right now.
Why not?
You gotta eat right, so your neuromuscular junction is ready to go.
What's the neuromuscular junction?
Well, once you get the go-ahead from the frontal lobe of your brain, the action potentials open your calcium channels.
So I have to have calcium.
So drink up.
Wow, I can really feel the synaptic vesicles fusing into my nerve terminal membrane.
That's great. Well, now the acetylcholine is released into your synaptic cleft, which opens your sodium-potassium channels. So here's a snack.
Wow, I can really feel the sodium flooding into my postsynaptic terminal.
Awesome. Well, now your muscle fibers are ready to go.
Cool. Wait, what happened to all the acetylcholine?
Well, that was reabsorbed and recycled into your presynaptic terminals.
Okay. Well, I think I'm ready to go now. What are you doing?
Well, if you want, you can join my session with my personal trainer, Magnus.
Ooh, Magnus. Okay, let's go work out with Magnus.
Let's go.
Sounds good.
Okay, Kanchi, time for a pretest. Yep, so tell me, what controls the force of a muscle?
Alright, so I think the excitation-contraction coupling controls the release of calcium, and then the calcium ends up controlling the force, right?
Correct. Great job.
So, Magnus, are we ready to work out now?
Not quite, Daisy. Before we work out, we gotta learn how muscle contraction works. After all, knowing's half the battle.
That's what you always say, Magnus.
I know. Anyways, first we initiate the contraction. Increased calcium levels in the cytosol lead to the calcium to bind to the troponin. Then the troponin pulls on the actin and exposes a myosin high affinity site. Okay, and the myosin head is going to bind to the actin, and then
Power stroke!
So is that all there is to muscle contraction?
no, not quite. See, muscle contraction is a cycle. We did the first stroke, but we got to go through the cycle and do it again.
Okay.
So how we're going to do that is by having the ATP bind to the myosin after the stroke. This is going to cause the myosin to lose its affinity to the actin, and it's going to detach. Okay? Next, ATP is going to hydrolyze on the myosin and form ADP plus a phosphate. This hydrolysis of the ATP is going to cause the myosin to have enough energy to reach for a farther away actin molecule. Next, we do the
Power stroke!
after the power stroke, ADP is going to release from the myosin, and the myosin is going to remain tightly bounded to the actin molecule. And then the cycle begins anew. So ready to work out?
Yeah, I think so.
Let's get to it. Okay, Kanchi, we're going to work out now. Are you ready?
Yeah, let's do it.
Let's do it. We're going to do a nice pump. I want you to do 10 flexion extension exercises. I want you to move the weight down and up, just like this. Go. Now see what's happening is when you're doing the flexion, when you're moving up, your bicep muscle is going to be contracting and it pulls the bones that are connected to the elbow closer together. Now the motion when you're going down, what that's doing is making your tricep contract. That pulls the bones farther apart. That's your extension.
extension, flexion, extension, flexion, extension, flexion.
Kanchi, great work. Lastly, we're going to take a nice jog to your apartment. You ready?
All right, let's do it.
Let's go.
All right.
Ooh, Kanchi, great run.
Thanks. I'm so tired though.
Tired, huh? What you got is a classic case of muscle fatigue. See, muscle fatigue comes from either central fatigue when the central nervous system isn't working, or peripheral fatigue when your peripheral things like the somatic motor neurons aren't working.
That doesn't make sense though, because like I had plenty of calcium in milk before I left.
Well then, I guess because we went from our run, your glycogen stores are pretty low. So to replenish those, we're going to eat up.
Alright. Man, when we were just jogging, I can like only imagine the sprinters and all the fatigue that they go through.
Yeah, they have some submaximal exertions, and that can cause some inorganic phosphate buildup, which can kind of mess with the whole phosphate group leading from the myosin, which plays a role in muscle contractions.
Oh man, no, what about the guys in the CRC, the big ones that were doing like all the chest presses?
Oh yeah, their maximal exertions can really make them tired. What happens is like potassium leaves the cell too much and it messes with the concentration gradient, so the sodium potassium pump mechanism won't work, so they're going to be pretty tired.
Alright, well.
Well, you did great, Kanchi.
Thanks, Magnus. I'll see you tomorrow.
See ya.
Alright.